The residential construction industry is experiencing increased costs due to rising copper prices. The price of copper, a crucial material in electrical wiring, has surpassed record levels from just a year ago. There are several factors driving these price increases. Firstly, increased demand. Enhanced infrastructure development, renewable energy projects, and the production of electric vehicles have all contributed to a greater demand for copper. Secondly, supply chain disruptions. The COVID-19 pandemic caused disruptions in the supply chain, hindering the production and distribution of copper. Thirdly, inflationary pressures. Rising production costs and the increasing cost of living have further driven up copper prices. These rising copper prices directly impact residential electrical costs. Specifically, the price of Romex, a common electrical wire in residential construction, has increased by $5 to $10 per 250-foot coil in recent months. There are exacerbating factors to consider as well. High oil prices are significant, as crude oil is a key component in producing wire insulation, which drives up costs. Additionally, there has been unexpected demand. The surge in home renovation and construction projects during the pandemic has led to unexpected demand for copper. While individual electricians cannot control the price of copper, there are mitigation strategies to lessen the impact on projects. One strategy is to use alternative materials. Consider using aluminum or steel for wiring in certain applications where appropriate and permissible by code. Another strategy is to optimize wire usage. Design electrical systems to minimize copper usage without compromising safety or performance, such as multi-wire branch circuits. A third strategy is to negotiate with suppliers. Explore negotiating with suppliers to secure better pricing on copper and related materials. Despite the challenges posed by rising copper prices, the residential electrical industry remains essential. By understanding the factors driving these price increases and implementing mitigation strategies, electricians can continue to provide safe and reliable electrical installations for homeowners. When considering alternative materials such as aluminum wiring, it is crucial to adhere to all applicable codes and standards such as those outlined in the National Electrical Code, or NEC. Aluminum wiring has different properties than copper, including a higher coefficient of thermal expansion and contraction and a lower conductivity. Therefore, special considerations must be taken during installation. Firstly, use only connectors and devices that are specifically listed and labeled for use with aluminum conductors. These connectors are designed to accommodate the expansion and contraction of aluminum and prevent oxidation, which can lead to loose connections and overheating. Secondly, apply an antioxidant joint compound to the aluminum conductors before making connections. This compound helps to prevent oxidation and ensures a good electrical connection. Thirdly, torque all connections to the manufacturer's specifications using a calibrated torque wrench. Over-tightening or under-tightening connections can lead to failures. Fourthly, when terminating aluminum conductors at devices such as receptacles and switches, be sure to use devices that are marked with CO/ALR, which indicates that they are suitable for use with copper or aluminum conductors. Fifthly, when splicing aluminum conductors, use only connectors that are listed for that purpose. These connectors are designed to provide a secure and reliable connection. Sixthly, after completing the installation, inspect all connections to ensure that they are tight and properly made. Periodically re-inspect connections, especially during the first year after installation, to check for any signs of loosening or overheating. Seventhly, consider the ampacity of aluminum conductors. Aluminum conductors have a lower ampacity than copper conductors of the same size. Therefore, it may be necessary to use a larger size aluminum conductor to carry the same amount of current as a copper conductor. Refer to NEC Table 310.15b16 for ampacity ratings of conductors. Eighthly, be aware of the potential for galvanic corrosion when aluminum conductors come into contact with dissimilar metals, such as steel or copper. Use appropriate separators or coatings to prevent direct contact between dissimilar metals. Ninthly, consult with a qualified electrical engineer or inspector to ensure that the installation meets all applicable codes and standards. 10thly, document all aspects of the installation, including the type of connectors used, the torque values applied, and the results of inspections. This documentation can be helpful for future maintenance and troubleshooting. By following these guidelines, electricians can safely and effectively use aluminum wiring in residential electrical systems, mitigating the impact of rising copper prices without compromising safety or performance. Also note that some jurisdictions may have local amendments to the NEC that further restrict or regulate the use of aluminum wiring. Always check with the local electrical inspector to ensure compliance with all applicable codes and regulations. Aluminum wiring is often used for service entrance conductors and larger feeder circuits where its lighter weight and lower cost can be advantageous, but it is less commonly used for branch circuits due to the specific considerations outlined above. For optimizing wire usage and designing electrical systems to minimize copper consumption while maintaining safety and performance, electricians should consider several key strategies. Firstly, utilize multi-wire branch circuits or MWBCs. MWBCs allow you to run 2 or more circuits using a single neutral conductor, reducing the total amount of wire required. For example, instead of running 2 separate 120-volt circuits with 2 hots and 2 neutrals, you can run a single 12/3 cable with 2 hots and 1 neutral, sharing the neutral between the 2 circuits. This can significantly reduce the amount of copper used, especially in larger homes with many circuits. Be sure to follow all NEC requirements for MWBCs, including the use of a common trip breaker or handle tie to disconnect all ungrounded conductors simultaneously. Secondly, use voltage drop calculations to optimize conductor size. Undersized conductors can cause excessive voltage drop, leading to inefficient operation of electrical equipment and potential safety hazards. Use voltage drop calculators or tables to determine the minimum conductor size required for each circuit based on the length of the run and the load current. You may be able to use a smaller conductor size than you would have otherwise, reducing the amount of copper used. Thirdly, minimize circuit lengths. Shorter circuit lengths result in less voltage drop and allow for the use of smaller conductor sizes. Plan the layout of electrical circuits to minimize the distance between the panel board and the loads. Consider locating panel boards closer to the center of the load distribution to reduce overall circuit lengths. Fourthly, use energy-efficient lighting and appliances. Energy-efficient lighting and appliances draw less current, allowing for the use of smaller conductor sizes. Encourage homeowners to use LED lighting, which consumes significantly less energy than traditional incandescent or fluorescent lighting. Fifthly, consider using demand factors when calculating service and feeder sizes. Demand factors allow you to reduce the calculated load based on the assumption that not all electrical equipment will be operating at the same time. Refer to NEC Article 220 for information on demand factors. Sixthly, use load management techniques to reduce peak demand. Load management techniques, such as time-of-use metering and demand response programs, can help to reduce peak demand, allowing for the use of smaller service and feeder sizes. Seventhly, consider using smart home technology to optimize energy usage. Smart home technology can help to monitor and control energy consumption, allowing homeowners to reduce their overall energy usage and minimize the demand on the electrical system. Eighthly, use the appropriate type of wiring for the application. Different types of wiring have different ampacity ratings and voltage drop characteristics. Choose the appropriate type of wiring for each application to optimize performance and minimize copper usage. For example, using THHN wire in conduit may allow for a higher ampacity rating than using NM cable. Ninthly, properly insulate and seal all electrical boxes and enclosures. Proper insulation and sealing can help to reduce energy loss and improve the efficiency of the electrical system. Tenthly, regularly inspect and maintain the electrical system. Regular inspections and maintenance can help to identify and correct any problems that may be causing energy waste or inefficiency. By implementing these strategies, electricians can design electrical systems that minimize copper usage without compromising safety or performance. Rising copper prices also underscore the importance of proper wire management and recycling practices. Electricians should make every effort to minimize waste and recycle any scrap wire or other materials. This can not only help to reduce costs but also contribute to environmental sustainability. Furthermore, staying informed about market trends and price fluctuations can help electricians make informed decisions about purchasing materials and managing project budgets. Consider establishing relationships with multiple suppliers to ensure access to competitive pricing and reliable supply. Also, explore options for purchasing materials in bulk or negotiating long-term contracts to secure better pricing. Finally, effective communication with homeowners is essential. Explain the impact of rising copper prices on project costs and discuss alternative options for mitigating these costs. Transparency and open communication can help to build trust and ensure that homeowners are aware of the challenges and opportunities associated with residential electrical work in the current economic environment. Another consideration to discuss with homeowners is the potential for future energy efficiency upgrades. Installing infrastructure for future solar panels or electric vehicle chargers during the initial construction phase can be more cost-effective than retrofitting later. This can also increase the value of the home and make it more attractive to potential buyers. Also, it is important to address any concerns that homeowners may have about the safety or reliability of alternative wiring materials or techniques. Provide them with accurate information and explain the steps that will be taken to ensure that the electrical system is safe and compliant with all applicable codes and standards. In addition to the strategies already mentioned, electricians can also consider the following to further mitigate the impact of rising copper prices. Firstly, pre-planning and accurate estimation. Thoroughly plan each project and accurately estimate the amount of materials required to minimize waste. Secondly, efficient installation techniques. Use efficient installation techniques to minimize the amount of time and labor required to complete each project. Thirdly, proper storage and handling of materials. Store and handle materials properly to prevent damage or loss. Fourthly, use of conduit fill calculations. When installing conductors and conduit, use conduit fill calculations to optimize the number of conductors in each conduit run. Fifthly, consider the use of parallel conductors. In some cases, it may be more cost-effective to use parallel conductors instead of a single larger conductor. Sixthly, use of cable trays or ladder racks. In commercial or industrial applications, consider using cable trays or ladder racks to support and route conductors. Seventhly, proper grounding and bonding. Ensure that the electrical system is properly grounded and bonded to prevent electrical shock hazards. Eighthly, use of surge protection devices. Install surge protection devices to protect electrical equipment from voltage surges. Ninthly, regular testing and maintenance. Regularly test and maintain the electrical system to ensure that it is operating safely and efficiently. Tenthly, staying up to date with industry trends and best practices. Stay up to date with industry trends and best practices to improve efficiency and reduce costs. By considering all of these factors, electricians can effectively mitigate the impact of rising copper prices and continue to provide safe and reliable electrical installations for homeowners and businesses. Remember to always prioritize safety and compliance with all applicable codes and standards. Cutting corners or taking shortcuts to save money can have serious consequences. Invest in quality materials and workmanship to ensure that the electrical system is safe, reliable, and efficient. In addition to the technical aspects of mitigating the impact of rising copper prices, electricians should also focus on building strong relationships with customers and suppliers. Building trust and rapport can lead to repeat business and access to better pricing and service. Be transparent and honest in all dealings, and always strive to exceed customer expectations. Finally, remember that the electrical industry is constantly evolving. Stay informed about new technologies, products, and techniques to remain competitive and provide the best possible service to customers. Attend industry events, read trade publications, and participate in continuing education courses to stay up to date. The challenges posed by rising copper prices also highlight the importance of promoting energy conservation and sustainability. encourage homeowners and businesses to adopt energy-efficient practices and invest in renewable energy technologies. This can not only help to reduce energy costs but also contribute to a cleaner and more sustainable environment. In summary, rising copper prices present a significant challenge to the residential electrical industry, but by understanding the factors driving these price increases and implementing mitigation strategies, electricians can continue to provide safe, reliable, and cost-effective electrical installations. This requires a combination of technical expertise, business acumen, and a commitment to customer service and sustainability.